Hello and welcome back to Nature of Code in Rust and GGEZ. We're taking a look at example 2.3, gravity scaled by mass. So if we reset our simulation here, this is roughly what we're going for, having all of the balls that we've created drop at the same rate, because that's how it looks in gravity. And how we do this is, before we implement gravity, we apply that force, we have to multiply it by the mass of that object. So let's go ahead and see what we need to in order to get that done. So inside of our main library, we have, let's see, so here's our gravity force. It's this vector 2. So we're creating it 1.0 down. Let's see, anything else? Then in update, we just apply force, gravity force. Okay, perfect. So we have our mover here, so we can actually grab the mass out of the mover. Let's make sure that the mass is public for us. So I'm gonna head into mover. When I do this, it's like trying to go to all the examples. I just opened everything up at once, and I don't know if that's super helpful. Head over here to mover. Yes, let's make this mass public so we can get access to it instead of having to create some kind of lens like a reader or a getter. And then we want to multiply, it's really just the y by it, don't we? That being said, the gravity has a 0, 0, so multiplying the x shouldn't affect it at all. So let's actually come into utilities to our vector 2 here. And I want to do a little bit of a clever, I want to replace our multiply scalar with impulse. You can just do like times and then a scalar f32. So if I want to do that, we're going to take this multiply scalar. I'm just going to remove this code. And down here, we're going to do an impl. So impl, oh, Rust Analyzer really doesn't like this. Give me 1 second. I'm just, oh, no. Okay. So impl, and then here we give it the type. It's going to be f32 or vector 2. We'll implement the missing numbers. What are we going to output here? It's going to be a brand new vector. So equal to be like that. And okay, so multiply, we have the right hand side. So what we're going to do, we're going to create a brand new vector 2 with the x as going to be self.x times right hand side, and the y is going to be self.y times right hand side. And so this is a nice way to allow us to just do like a multiply or a multiply self also. So we're going to do that too. So impl mul assign. Rust Analyzer is super unhappy. Yeah, I'm going to pause really quickly and I'll be right back as I switch out to a different, I can't even say. I'm going to close down this editor and open back up with everything else gone, just in this specific directory. So I'll be right back. All right, I am back, and things should be a little bit faster now. My entire computer was starting to slow down. It was trying to process everything. So let's go ahead and make sure that this is correct. So mul, we do have to let Rust Analyzer work on everything. I just brought it in. So we don't have mul assign in here, but we should be able to add this in. So mul assign, I believe that's part of standard ops. And then here we're going to impl, we'll assign F32 for a vector 2. Let's see, the Rust analyzer is still working and thinking. Is it going to be done any second now? There it goes. So now I should be able to, maybe, possibly, is it? Let's try this again. We'll assign F32 for vector 2. There we go. Implement missing members. So here we have our mute self and the right-hand side. So we're just going to say self.x times equals right-hand side, self.y times equals right-hand side. All right. And this is a really nice way for us to be able to come back. Let's see. What's up? What are you upset about here? Oh, so multiply scalar. So this is a multiply scalar here. And we're trying to mul assign it here. So really what we can do is start equals to max now. That's what we've just given ourselves the ability to do. It's let's see, cannot use binary assignment, start equals cannot be applied to type. Vector, mutable reference to vector 2. Oh, I think what we have to do is we have to dereference the self here to make sure we have like the actual vector 2 instead of just a reference to it. And then same exact thing here. So we have vector 2, and we're going to times equals this scalar. All right, so we should be good here. Movers, I think you must, yep, you're using multiply scalar as well. So times equals 0.0. And okay, we're good to go. Let's head back into the main library here. So in update, what we want to do is we want to get a copy of gravity in here. So let's get like a gravity copy. So we'll just call this gravity. You're going to be equal to our, you know what? We can actually do this inside of here because it's going to be unique per one. So gravity force equals this. I actually want, now it looks like I'm taking ownership of it, but because we're in a loop, it's going to realize that this needs to clone it. Which is going to be super helpful. So I actually want you to become mutable here. Then we're going to say gravity force times equals the mover dot mass. So we're going to multiply the mass by the gravity force, and then we're going to apply a reference to this gravity force. All right. Oh, cannot borrow self out of here. What's immutable borrow? So 45 and 46. Oh, because of self. So you know what? Unfortunately, we do need sort of like a gravity force and like a copy of the gravity. So we can just do let mute gravity. We could even shadow this. Gravity force equals gravity force. You don't need to be immutable anymore. You can just be that. And just changing the order that we're doing things, that makes the borrow checker a little bit happier. Okay, so we apply the force. Let's see what happens when we run this. All of the balls now fall at exactly the same rate. They bounce at a different rate. We could play around with our actual gravity force in here. We can make you maybe a little bit stronger. We can change like the wind force. But the idea is that they are falling at their own separate rates. What might be really helpful here is instead of changing this, we could change the mass of the mover. So right now, your mass is random between 10 and 35. So let's make this really small. Let's make this anywhere between like maybe 1 and 10. And that should make it a little bit easier. Yeah, it bounces a little bit more now. And we can like have the mouse, times like maybe 5 to make them a bit bigger. We can make this maybe anywhere between 1 and like 1.5, maybe even 0.5 and 5. These numbers are always like fun to sort of tweak and see exactly what happens. They should be, let's actually not have 0.5. That might be screwing up my calculations here. Let's have between 0 and 10 for our, I don't think, let's see, mass times 2. What are you want the X and Y. The X and Y, we want that in the right position. So the times 2, I think, is right. The mass, context. I think in our mover, we could have our radius is just equal to mass. Going to be equal to mass times like 10. That will make them a little bit bigger, a little bit easier to see. As they all fall at the same time, and then they bounce around. And that's the general idea of what we're going for here. And now it doesn't look exactly the same as what we have in, but the general idea is the same, which is everything falls at the same rate as they would in real nature. So that is example 2.3, gravity scaled by mass. I'll see you in the next video. Thanks. Bye.